Will Earth ever lose its moon? The moon is slowly creeping away from Earth, but will we actually lose the moon before the sun turns into a red giant and destroys us both, Earth and the moon? The moon's orbit around the Earth appears so regular that civilizations have based the moon on lunar motion for thousands of years. However, the moon is actually creeping slowly away from Earth, so will Earth lose its moon at some point? Scientists determined the rate at which the moon is drifting away from Earth with help from the reflective panels that NASA placed there during the Apollo missions. For more than 50 years, researchers have fired laser beams from Earth at these mirrors and measured how long it took to detect the reflected pulses. And using the speed of light, scientists estimate that the moon is straying away from Earth at about 1.5 inches every single year, roughly the rate at which fingernails grow, according to NASA. And we know that the Earth is growing at the rate of a fingernail growth every year as well. Now, the moon is moving away from Earth because of the gravitational effects that each has on the other. The moon's gravitational pull forces Earth's oceans to bulge towards it, resulting in the lunar tides, NASA said. Earth's gravity causes similar tide effects on the moon, making our natural satellite slightly football-shaped. The gravitational pull from Earth's tidal bulge drags on the moon. Meanwhile, the ocean shifts because of the lunar tides, exerting friction on Earth's surface and thus slowing the planet's rotation. Madeline Broom, the astrophysicist at the University of California, Santa Cruz, told Life Science. About 4.5 billion years ago, when the moon was first formed, according to theories, the rotation rate of the Earth would have been significantly faster, with a day length of about only 5 hours, Broom said. All of these forces work to sling the moon farther away from Earth. Since the Earth and the moon are part of the same gravitational interacting system, total angular momentum must be conserved, stay the same, that is, between the two, Broom explained. Angular momentum describes the energy contained by something that is spinning. The faster you spin, the more angular momentum you have, and the slower you spin, the less. However, it's not just the rate of spinning that affects angular momentum, Broom said. How far you are from the center of the system also matters. Further means the angular momentum of the system goes up, and closer means your angular momentum goes down. In the case of the Earth and the moon, as the Earth's spin slows down in order for angular momentum to be conserved, something has to increase the angular momentum of the system, Broom said. What increases angular momentum? An orbiting object like the moon getting farther away. The moon likely formed from debris that resulted from a crash between the nascent Earth and the Mars-sized object, according to the University of Arizona. Tidal forces have helped pull the moon to its current average distance of about 238,855 miles from our Earth, according to the Royal Observatory in Greenwich, England. That's about 384,400 kilometers. Tidal effects are also slowing the rate at which the moon rotates on its axis, resulting in the moon tidally locking with Earth. That is, always displaying the same face to our planet. These forces are also reducing the speed at which Earth spins. In about 50 billion years, Earth's slowing rotation would make it tidally locked with the moon, so that Earth would permanently show just one side to the moon. John Creighton, director of Manfred Olson Planetarium at the University of Wisconsin-Milwaukee, told Life Science. At this point, the moon and Earth would stop moving away from each other. Eric Klump, professor of astronomy at Middle Tennessee State University, told Life Science. However, about 5 billion years from now, as the sun begins to die, it will swell to become a red giant star, at which point the Earth-Moon system will almost certainly be disrupted and destroyed. David Trilling, chair of the Astronomy and Planetary Science Department at Northern Arizona University, told Life Science. In about 5 billion years, if the moon keeps drifting away from Earth at its current rate of retreat, the moon will have moved out about another 117,000 miles away when it gets consumed by the red giant sun, Broom said. All in all, the moon will not leave Earth, or vice versa. Rather, the sun will obliterate them both. And this is by Charles Chu Choi on Life Science. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.